Hi, good morning to all of you. My name is Surjit, Dr. Surjit. I'm going to present here Unit 5, 4th semester, B Pharmacy, Narcotics and Non-Narcotic Analgesia, and I will cover the SAR of structural activity relationship of morphine. So this is the syllabus of B Pharmacy Unit 5, 4th semester, and you can see here in the morphine related drugs, the SAR is here present crucial. SAR we have to cover it. So first I will go for the introduction that what is opioids. So opioids are the class of drugs, mainly the natural substances. We get it from the natural substance found mainly in the opium poppy plant. Here you can see opium poppy plant, and it mainly works on the opioid receptors that is present in the brain and other organs to produce a variety of morphine like effects, including the pain relief analgesic effect. So this is the poppy plant and its scientific name is Papaver somniferum. So from the poppy plant we get the our morphine structure, which mainly alters the behavior and also cause the addiction. And one of the main use of this opioid is pain relief. Pain relief, that we can also say that analgesic effect. So it is mainly two types, narcotic and non-narcotic. So this morphine comes in the narcotic category part. So what is the mechanism of action of such drugs? So first of all, morphine activates the mu, kappa and delta receptors, that is mainly activating these type of receptors and helping in the pain relief purpose. So there is a phenomena that is also occurring, that is known as hyperpolarization, when the morphine is attacking to the receptor sites, and one ion gated channel, the influx of chloride ions and efflux of potassium ion goes on. So these are the morphine characteristics. How does it look, what are the structure, and how it gives the analgesic effect. So we will cover the structural activity relationship of this structure. So this is the idea that was presented by two great scientists. First of all is Thomas Fraser, and second one is Alexander Crum Brown in 1868. So these are the they said that the connection between the molecular chemical structure which will affect the biological activity. If we change of, or if we alter or modify the chemical structures, then it will also change to the biological activity. And nowadays we are using this idea to our drug optimization purpose, to reduce the toxicity level of the drugs, cost reduction in the process, and also we are synthesizing the new compounds, new novel compounds, or new compounds for the diseases. So first of all, to study the SAR of morphines, we have to study the whole structure of the morphine. Like there are 5 rings present in the morphine structure. If you see, first one is A, B, C and D and E. In the A ring, you can see here, A ring is aromatic ring. We also call is phenolic ring. B is cyclohexane ring. C is alcoholic ring. D is our tetrahydrofuran ring, and E is piperidine ring. So these are the main rings that is present in the morphine structure. So as we studied this, and what is the SAR, if we changes something, we are getting something in biological activity. So you can see here in the A ring of the phenolic ring, and at the C3 positions, you can see here that the free phenolic group provides optimum mu receptor affinity. As we see in the mechanism of action, that morphine goes to the mu, kappa and delta. So here this is very crucial. This hydroxy group is very much crucial for the activation of the mu receptor affinity. Second one is it decreases the LWPC, that is lipid-water partition coefficient. So here we are talking about the log p value. Here we are talking about the log p value. but it leads to the first pass glucuronidation, which results in poor viability. So you can see the what is the importance of this hydroxy group to the to attacking or activating the mu receptors. Second one is etherification at C3 position. When we put CS3 group on this position, C3 position, it yields the codeine, which is more potent than the morphine. So it decreases the affinity for the immune receptor, but it is a pro drug. I will give it this concept later from the later video. So this is a pro drug. After metabolizing to the morphine, it directly goes to the mu receptors. If you talk about the B ring that is present here, it mainly gives the rigid conformation of morphine, ensuring the A to C ring system aligns properly. So it generally gives the rigidity, that B ring. If we talk about C ring that is present here, on the C6OH group, we are talking about here this hydroxy group. It is very much essential for the hydrogen bonding, to the our receptor. Yeah, and if we convert this hydroxy group to the ketone group, you can see the potency is getting increased. So as we said, SAR is changing something and we are increasing the biological impact. So increasing the potency due to the better receptor interactions. Coming to the D ring, that is tetrahedron furan ring. We are talking about this ring. So this ring mainly, it is a saturated ether bridge forming a 5-membered furan-like ring, gives the molecule its characteristics 3D T-shaped conformation. So that is very much crucial for the receptor or morphine binding. And it is also critical for the conformation integrity of morphine. So it helps to lock the pharmacophore or the ligand into the favorable orientation. So this tetrahedron furan ring is very much crucial for the receptor and morphine interactions. Coming to the last E ring, the E ring is morphine is a 6-membered piperidine ring, and it contains a basic nitrogen on the 17th positions. On the 17th position, typically N-methylated, which is very much vital for the binding to the mu opioid receptors. And we can observe that third degree amine is important for the activity. And we also observe that N-methyl substitutions show good agonist activity. So if we have a methyl group on the position of CS3, we are getting our agonist activity. We are getting agonist activities. And third point, and which is very much crucial point, that is increasing the number of carbon at the 17th position. Increasing the number of carbon on the 17th position gives antagonist activity. That is your naloxone. This structure is naloxone. So this work as antagonist. So this is all for today. Thank you.